What was the vision, the dream of Autopilot when in the beginning, the big picture system level, when it was first conceived and started being installed in 2014 in the hardware in the cars? What was the vision, the dream?
I wouldn't characterize it as a vision or dream. It's simply that there are obviously two massive revolutions in the automobile industry. One is the transition to electrification, and then the other is autonomy. And it became obvious to me that in the future, any car that did not have autonomy would be about as useful as a horse. Which is not to say that there's no use, it's just rare and somewhat idiosyncratic if somebody has a horse at this point. It's just obvious that cars will drive themselves completely. It's just a question of time. And if we did not participate in the autonomy revolution, then our cars would not be useful to people relative to cars that are autonomous. I mean, an autonomous car is arguably worth 5 to 10 times more than a car which is not autonomous.
In the long term.
Depends what you mean by long term, but let's say at least for the next 5 years, perhaps 10 years.
So there are a lot of very interesting design choices with Autopilot early on. First is showing on the instrument cluster or in the Model 3 on the center stack display what the combined sensor suite sees. What was the thinking behind that choice? Was there debate? What was the process?
The whole point of the display is to provide a health check on the vehicle's perception of reality. So the vehicle's taking in information from a bunch of sensors, primarily cameras, but also radar and ultrasonics, GPS, and so forth. And then that information is then rendered into vector space, and that, with a bunch of objects with properties like lane lines and traffic lights and other cars, and then in vector space that is re-rendered onto a display, so you can confirm whether the car knows what's going on or not by looking out the window.
Right. I think that's an extremely powerful thing for people to get an understanding, so to become one with the system and understanding what the system is capable of. Mm-hmm. Now, have you considered showing more? So if we look at the computer vision, like road segmentation, lane detection, vehicle detection, object detection underlying the system, there is at the edges some uncertainty. Have you considered revealing the parts that the uncertainty in the system, the sort of
probabilities associated with say image recognition or something like that?
Yeah. So right now it shows like the vehicles in the vicinity, a very clean, crisp image, and people do confirm that there's a car in front of me, and the system sees there's a car in front of me. But to help people build an intuition of what computer vision is by showing some of the uncertainty.
Well, I think it's in my car. I always look at the sort of the debug view, and there's two debug views. One is augmented vision, which I'm sure you've seen, where it's basically we draw boxes and labels around objects that are recognized, and then there's what we call the visualizer, which is basically a vector space representation summing up the input from all sensors. That does not show any pictures, but it shows all of the. It basically shows the car's view of the world in vector space. But I think this is very difficult for normal people to understand. They would not know what the heck they're looking at.
So it's almost an HMI challenge to the current things that are being displayed is optimized for the general public understanding of what the system is capable of.
It's like if you have no idea how computer vision works or anything, you can still look at the screen and see if the car knows what's going on. And then if you're a development engineer, or if you have the development build like I do, then you can see all the debug information. But those would just be like total gibberish to most people.
Right. What's your view on how to best distribute effort? So there's 3, I would say, technical aspects of Autopilot that are really important. So it's the underlying algorithms, like the neural network architecture. There's the data, so that it's trained on, and then there's the hardware development. There may be others, but so look, algorithm, data, hardware. You only have so much money, only have so much time. what do you think is the most important thing to allocate resources to? Or do you see it as pretty evenly distributed between those three?
We automatically get vast amounts of data because all of our cars have 8 external facing cameras and radar and usually 12 ultrasonic sensors, GPS obviously, and IMU. And so we basically have a fleet that has, and we've got about 400,000 cars on the road that have that level of data. Actually, I think you keep quite close track of it, actually.
Yes.
Yeah, so we're approaching 500,000 cars on the road that have the full sensor suite.
Yeah.
So this is, I'm not sure how many other cars on the road have this sensor suite, but I'd be surprised if it's more than 5,000, which means that we have 99% of all the data.
So there's this huge inflow of data.
Absolutely, massive inflow of data. And then it's taken us about 3 years, but now we've finally developed our full self-driving computer, which can process an order of magnitude as much as the NVIDIA system that we currently have in the cars. And it's really just to use it, you unplug the NVIDIA computer and plug the Tesla computer in, and that's it. And it's in fact, we're still exploring the boundaries of its capabilities. But we're able to run the cameras at full frame rate, full resolution, not even crop the images. And it's still got headroom, even on one of the systems. The full self-driving computer is really 2 computers, 2 systems on a chip that are fully redundant. So you could put a bullet through basically any part of that system and it still works.
The redundancy, are they perfect copies of each other? Or
Yeah.
Also it's purely for redundancy as opposed to an arguing machine kind of architecture where they're both making decisions? This is purely for redundancy.
I think of it more like it's if you have a twin-engine aircraft, commercial aircraft, the system will operate best if both systems are operating, but it's capable of operating safely on one. So, but as it is right now, we can just run. We haven't even hit the edge of performance, so there's no need to actually distribute functionality across both SoCs. We can actually just run a full duplicate on each one.
So you haven't really explored or hit the limit of the system?
We've not yet hit the limit, no.
So the magic of deep learning is that it gets better with data. You said there's a huge inflow of data, but
Yeah.
the thing about driving, the really valuable data to learn from is the edge cases.
Mm-hmm.
So how do you, I mean, I've heard you talk somewhere about autopilot disengagements being an important moment of time
Yes.
to use. Is there other edge cases, or perhaps can you speak to those edge cases, what aspects of them might be valuable, or if you have other ideas how to discover more and more and more edge cases in driving?
Well, there's a lot of things that are learned. There's certainly edge cases where, say, somebody's on autopilot and they take over, and then okay, that's a trigger that goes to a system that says, okay, did they take over for convenience, or did they take over because the autopilot wasn't working properly? There's also, like, let's say we're trying to figure out what is the optimal spline for traversing an intersection. Right. Then the ones where there are no interventions and we, are the right ones. So you then say, okay, when it looks like this, do the following, and then you get the optimal spline for a complex navigating a complex intersection.
So that's for this. So there's kind of the common case. Mm-hmm. So you're trying to capture a huge amount of samples of a particular intersection, when things went right, and then there's the edge case where, as you said, not for convenience, but something didn't go exactly right.
Somebody took over. Somebody started manual control from autopilot, and really, like, the way to look at this is view all input as error. If the user had to do input, there's something. All input is error.
That's a powerful line to think of it that way, because it may very well be error. But if you want to exit the highway, or if you want to, it's a navigation decision that all autopilot is not currently designed to do, then the driver takes over. How do you know the difference?
That's going to change with Navigate and Autopilot, which we've just released. and without stall confirm. So the navigation, like lane change based, like asserting control in order to do a lane change or exit a freeway or do a highway interchange, the vast majority of that will go away with the release that just went out.
Yeah, so that I don't think people quite understand how big of a step that is.
Yeah, they don't.
So
if you drive the car, then you do.